So far we've just been looking at whole numbers, well, integers, positive or negative. So now we start looking at fractions. Okay, so chapter 3, fractions and mixed numbers. All right, so yeah, you've all seen fractions before, so they look like this. We have a top number called the numerator, that's the fancy name, a fraction bar, and then on the bottom the denominator. And how would you read this fraction? Well, you could just say it's 3 over 8, or maybe better is 3/8. And yeah, this the second word isn't eighths, it's eighths with a th. Yeah, so for fractions you need that th usually. So 3/8. And so yeah, so what does that mean? So what does 3/8 mean? Well, yeah, you might have seen on a say a ruler. So 3/8 of an inch. So if you're measuring something like this, well, if this is 1 inch, and you break the inch into 8 equal pieces, so this will be 1/8, 2/8, 2/8, and 3/8. Okay, so 3/8 of an inch. It's not a full inch. It's not even half an inch. It's less. It's this much of an inch. Well, yeah, that's one way to think of it. Another way is just take the top number and divide it into 8 equal pieces. Okay, so you'll get this same. So if you start with 3 and divide 3 into 8 equal pieces, this will be the size of one piece. But yeah, easier to divide 1 into 8 equal pieces and then take 3 of those pieces. Okay, so this fraction 3 over 8, you can also write it like this, and this fraction bar, you can write it as a / as well, or like this, so it means division. Okay, so it's 3 divided by 8, so dividing 3 into 8 equal pieces. If you do that, each piece has to be of size 3/8. So yeah, so these fractions, it's telling us more than, our previous way of looking at division in terms of quotients and remainders. So in that language, we're saying, we could say, so 8, well, 3 divided by 8, how many times does 8 fit into 3? Well, it fits in 0 times, and how much of 3 is left over? Well, all of 3. So in terms of quotients and remainders, 3 divided by 8 is equal to 0 remainder 3. But yeah, that's not a very helpful way to think about 3 divided by 8. Okay, so yeah, we'll look at other ways to understand 3/8. But this is just, again, yeah, just introducing fractions. So numerator, don't forget that's the top number, denominator is the bottom number. And we're really talking about division. So this whole chapter is about division. What's a mixed number? Okay, so that's mixing whole numbers and fractions. It might look like we're multiplying this 2 by this 3/8, but in fact this mixed number notation really means we're adding. Okay, so that's a source of some confusion. And so when you see a mixed number like this, it really means we're adding 2 plus 3/8. So going back to your ruler with inches, so 2 3/8 inches. So here's 1 inch, 2 inches, 2 1/8, 2 2/8, 2 3/8. Okay, so this whole thing is 3 inches, and this part is 2 3/8 inches. Okay, so it's really, when you see a mixed number, you should always think there's really a plus sign. There's really a plus sign in between the two numbers. Okay, we'll come back to mixed numbers, but let's just work on fractions first. Different ways to picture fractions, but let's see. Look in the book, more examples here. How do you say fractions? This is 1/8. This is 6/13. Again, when the 13 is down here, it's a 13th. If the denominator is 2, then you're talking about halves. If the denominator is 4, then 3/4 here, or 3/4. Okay, in terms of money, if somebody gives you 3/4, then you've got 3/4 of a dollar, or 3/4 of a dollar. You need one more quarter to get the full dollar. Okay, so when we're thinking about fractions, you should maybe have a picture. So try to picture what these fractions look like. So what does it mean to eat 3/8 of a pizza? So going back to our example, 3/8. So what's 3/8 of a pizza? Well, that just means 3 slices. So pizzas are usually sliced into 8 hopefully equal slices. Okay, so for our fractions, they have to be equal slices. So if we just shade in 3 of these 8 slices, so the shaded part represents 3/8. Okay, so the whole pizza, that's 8/8, so that's all 8 slices. So that counts as 1. Okay, that's the whole thing. If you just eat 1 slice, you're eating 1/8 of this pizza. Okay, so you can draw 3/8 like this. You can use any shape. just the point is you want to be able to cut the shape up into 8 equal pieces and then shade in 3 of them. Okay, so for this rectangle, it's got, I've divided it up into 8 equal smaller rectangles, and shading in 3 of those, we get 3/8. Okay, if you wanted 7/8, you just shade in 7 of the rectangles. Okay, so 7/8 would look like this. Just leaving one not shaded in. Okay, so I don't know if that makes sense. And yeah, so for these pictures, it is important that the pieces have equal sizes. Yeah, so I've broken this rectangle into 8 pieces, but not all the same size. So now it doesn't work. So this is not 3/8 of the rectangle. It's more like 1/2, 4/8. Okay, so just try to. Okay, it doesn't have to be perfect, but try to make the pieces the same size. Example 1, use a rectangle to represent 3/5, 3/5. Okay, so the bottom number tells you how many pieces you want to break up the rectangle into. And the top number tells you how many to shade in. Okay, so it's 3 on top, so we're shading in 3 again. But this time there are 5 roughly equal pieces for this rectangle. Okay, so 3/5 looks like this. So is 3/5 bigger than 1/2? So yeah, you can see, just at least the way I've drawn it, more than half of this rectangle is shaded, so 3/5 is bigger than 1/2. Example 2, what fraction does this picture represent? Okay, so back to a circle here. So it looks like 3 pieces have been shaded. 2 pieces are not shaded, so altogether there are 5 pieces, and we've shaded 3 of them. So the answer is 3/5 again. No, so you can see we need all the pieces to be the same size. So if we go back to our pizza, yeah, so now they have the same size. So now we can see more clearly that this is, we have 8ths, and we've shaded in 1, 2, 3, 4, 5. So the shading is really represents 5/8. So five slices of the pizza. So these are 8 equal size pieces. All right, so again, the point I'm trying to make is, yeah, the pieces have to be the same size. Okay, another way to picture these fractions is on the number line. Okay, so here's the number line. We've got the whole numbers we're used to at 0, 1, 2. Over here would be -1. Okay, so where are the fractions that we've been looking at? Well, 3/8 is between 0 and 1. It's between those whole numbers. And in fact, it's 3/8 of the way from 0 to 1. So if you just break up this interval into 8 equal pieces again, so this is 1/8, 2/8, 3/8 is there. 4/8 gets you halfway, 5/8, 6/8, 7/8, and 8/8, you're at 1. Okay, you can keep going, 9/8, 10/8, right? But 3/8 is definitely here. All right, so these fractions, they're the numbers between the whole numbers. We also looked at 3/5. So where is 3/5? Well, now we're 3/5 of the way between 0 and 1. So this is 1/5, 2/5, 3/5 is here, 4/5, 5/5. That would be 1. That's the whole rectangle or the whole circle. Okay, so drawing fractions on the number line. I hope that makes sense. It's just like a ruler. Certainly these eighths. You're just marking off points on a ruler. Okay, more pictures in the book. So this rectangle's broken into 3 equal pieces, 2 of them shaded, so that's 2/3. Yep, we looked at 3/5. Yeah, this is another a circle picture for 3/5. Example here, use a square to represent the fraction 5/16. So yeah, we get a different kind of picture. So here the square is broken into 16 smaller squares and shade in 5 of them. So this is 5/16 of this square is shaded in. All right, so that's picturing fractions just to get an idea what they mean. So it's just, we're looking at kind of parts of the whole. Okay, next section, proper and improper fractions. Okay, so our fractions look like this again. So say a over b. A is the numerator here, b is the denominator. Let's assume these are both positive numbers for now. So this fraction is proper if a is strictly less than b. Okay, so we want, if the top number is smaller than the bottom number, then that's called a proper fraction. Otherwise, the fraction is improper. Okay, so if the top number is the same size or bigger than the bottom number, then you're working with an improper fraction. So these fractions here, these are all proper. So 1 is less than 2, 7 is less than 8, 0 is less than 6, and 19 is less than 137. So these are all proper fractions. but these ones down here are proper. So 3 is bigger than 2. 6 is equal to 6. So if they're equal, that's an improper fraction. And the tops here are bigger, so these are all improper. All right, so any fraction, well, any positive fraction, you can classify it right away as proper or improper. Now the proper fraction, so if the top number is less than the bottom number, then that fraction is always going to be less than 1. Okay, so you're always going to have less than the full pizza. But improper fractions are they're going to be 1. They could be 1 or bigger than 1. Yeah, this 6 over 6, this is improper, and this represents 1. Example 3 here. Use rectangles to draw the proper fraction 4 over 7, 4/7, and also the improper fraction 7 over 4, 7/4. Okay, so these are two different fractions, the same numbers, but top and bottom switched. Okay, so let's see what they look like. All right, so 4/7. Okay, again, the bottom number, that's telling you divide the rectangle. Yeah, we're using rectangles here. Divide the rectangle into 7 roughly equal pieces and shade in 4 of them. Okay, the top number tells you how many to shade. Okay, so 4/7. Yeah, it's less than 1, so less than the full rectangle. Okay, but what about 7/4, 7/4? Okay, so this bottom number 4 here is telling us to divide the rectangle into 4 equal pieces and shade in 7. Okay, so here we've divided this rectangle into 4. We've shaded 4, but we need more. We're looking for 7 of these pieces, so we need another rectangle. So divide this rectangle into 4. So now we can see more clearly. So these are we've shaded 7/4, and the answer is, so this number is bigger than 1. It's you can think of it as 1. This is 1 plus another 3/4. Okay, so these proper numbers, these improper fractions, they're 1 or more. This one's bigger than 1. It's 1 plus another piece. And right, so here, yeah, each whole number, each whole rectangle represents 1. Example 4, what fraction does this picture represent? Okay, so we have a whole rectangle, another whole rectangle, and this rectangle is divided into 3 equal pieces with one of them shaded. Okay, so this, just by itself, this is 1/3. But we also have 3/3 from this rectangle, another 3/3 here, so that's 6/3, plus one more So that's 7/3 altogether. Okay, so this last guy tells us we're dealing with thirds, so you can see how many thirds do we have altogether. 1, 2, 3, 4, 5, 6, 7. So 7 of these thirds are shaded in, so this whole thing represents 7/3, another improper fraction. Okay, some simple fraction families. Okay, so if we have a number a over a, say a is a positive integer, and a over a, that's an improper fraction, and this is always equal to 1. Yeah, we saw 6 over 6 before, or 8 over 8. Any number, 117 over 117, that just represents 1. So the whole rectangle will be shaded in. So just one hole, one rectangle, or one circle. Okay, so anytime you see a fraction like this, it simplifies to 1. Okay, another case here, if you have a over 1, so if the denominator is 1, okay, so this will be another improper case. Okay, I'm assuming that the top number is not 0, but if a is any positive integer, then this will be improper. But here, yeah, you're just dividing the rectangle into just one piece. So really you have a of these rectangles. Okay, so this fraction is really a whole number. It's really just a. Yeah, in terms of division, yeah, so that first guy, a fits into a 1 time. Here, 1 fits into a times. So this is just a. So this is really a whole number. Yeah, and if you want to convert a whole number into a fraction, just put a 1 underneath. Okay, that's an improper family. Here we have a proper family. Yeah, if the top number is 0, and b is some positive integer, then we saw this before. Yeah, you're not shading in anything. So if nothing's shaded, then that number is 0, or b fits into 0 0 times. Okay, so yeah, if you have a fraction with a 0 on the top, then that whole thing is just 0. There's nothing there. Okay, here we're assuming b is not 0. If the bottom is 0, it doesn't matter what the top is. If the bottom is 0, if the denominator is 0, then that fraction is undefined. So that's the problem case. Again, we're not allowed to divide by 0. It doesn't make sense to divide by 0. Okay, so fractions with a 0 on the bottom don't make sense. That's undefined. But fractions with a 0 on the top, that does make sense. Those fractions are just 0. Okay, so yeah, pay attention to those two cases. So this example, yeah, just a bunch of fractions to simplify. Okay, 4 over 1, that's just 4. And 9 over 9 is 1. 0 over 9 is 0. Here another case, a over a, that's 1. 0 on the bottom, undefined. 3 over 1 is 3. Okay, so those are just examples of these 4 cases. Yeah, that's, again, yeah, a over a is 1. A over 1 is a. And 0 over b is 0. And if the denominator is 0, then that's undefined. Yeah, about this picture. What improper fraction does this picture represent? Okay, so here you can see we have 5/6. So in terms of sixths, this we have another 6 here and another 6 here. So how many sixths altogether? 6 plus 6 plus 5, 17. Okay, so this picture represents 17 over 6. Okay, now we can get back to mixed numbers. So we're mixing whole numbers and fractions. Okay, yes, so back, what was example 4? Yeah, this was, so this picture represented 7 over 3. And yeah, we saw that we have 2 full rectangles, so this is, think of this as 1 plus 1. And this is 1/3 of this rectangle. So another way to think about 7/3, it's really 2 plus 1/3. So as a mixed number, you can write it so 7/3. Okay, the kind of separating out the whole number pieces. You have a 2. There's still a 1/3, a fraction piece left, so it's 2 plus 1/3. As a mixed number, that's 2 and 1/3. Written like this, you just push the 2 pieces together. Again, it doesn't mean multiplication, it's really addition. And the idea is if you start with any improper fraction, okay, where the top is bigger than or equal to the bottom, then you can always make improper fractions into mixed numbers. And often that's a better way to understand. It's often more useful to write a improper fraction as a mixed number. Easier to see what's happening. If you were going to graph this 7/3 on the number line, then yeah, this is kind of more useful. You see, you're just 1/3 of the way past 2. Okay, so example 5. Okay, let me give you this improper fraction, 13/4, 13 over 4. Can we write this as a mixed number. Okay, yeah, so you could draw the rectangles, but let's try to do it without rectangles. So how many whole numbers are in here? Yeah, so we're talking about quarters. So every 4 quarters gives us a whole, number, gives us a 1. So inside that 13, how many 4s are there? Well, 13 is 4 plus 4 plus 4, that's 12, and there's 1 left over. Yes, if you were drawing the rectangles, this would be a full rectangle, another one, a third, and then 1 out of the 4 quarters shaded in the 4th rectangle. Okay, so 13 over 4, this improper fraction is equal to 3 plus 1/4 left over. So as a mixed number, it's 3 1/4. All right, so I hope that made sense. Yeah, we can understand it. Maybe the better way to think of it is, going back to division with a remainder. Okay, so we're dividing 3 by 4. 4 fits into, 13. We're dividing, how many times does 4 fit into 13? Well, it fits 3 times, that's the quotient, and 1's left over, remainder 1. So these are exactly the 2 numbers we need. That quotient, that gives us the whole number piece, and the remainder 1, that tells us how many quarters are left, so 1 over 4. Okay, so yes, this is a nice application of our division with quotients and remainders. Okay, so we can use it to convert any improper fraction into a mixed number. Just do the division. The quotient gives you the whole number piece. The remainder gives you the top of the fraction, and the denominators are the same. So 4's, keep that 4 on the bottom. Example 6, let's try another one of those. We want to write 82 fifths as a mixed number. Okay, so we have 82 divided by 5. So how many times does 5 fit into 82? Okay, so we're dividing 82 by 5. So the 5 has to go on the outside. Yeah, I've already seen some homeworks where it's the wrong way around. Okay, but we're dividing the 5 into the 82. So first 5 goes into 8 one time. Put the 1 above the 8. 1 times 5 is 5. Subtract. 5 from 8 is 3. Bring down the 2. So now we're looking at 32. 5 goes into 32 6 times. 6 goes here. 6 times 5 is 30. Subtract. Okay, so the remainder is 2. Yeah, just when you're doing division, it's important to keep things lined up. So 5 goes into 8 one time. Put the 1 above the 8. And then, yeah, you still have to fill in a number over the 2. But once you have that 6, then you're finished. Then the remainder is that number left over, that 2. Yeah, so in the homework, that first homework, people kept going. Yeah, so if you want a decimal, then you keep going, but we don't want a decimal here. We just want that remainder. Okay, so the quotient here is 16, and the remainder is 2. So that quotient tells us the whole number piece of the mixed number. So 82/5 is equal to 16 and 2/5. Right, so yeah, so that makes sense. So this is saying, yeah, so 18 fits into, 5 fits into 82 16 times. So we have 16 full rectangles, and there's 2/5 left over, so it's 16 and 2/5. Okay, how about 84 sevenths? Can we convert that to a mixed number? So we can do it the same way. So we're dividing 7 into 84. Okay, so another long division. We get 12, and this time the remainder is 0. So 84 sevenths is equal to 12 and 0 sevenths. Okay, so again, the quotient is 12, the remainder is 0, put it over 7. Okay, but 0 sevenths, that looks strange. Yeah, we saw one of our families, any fraction with a 0 on the top, that's just 0. Okay, so this piece is 0, so it's 12 plus 0, so we can, again, ignore it. So the answer is just 12. All right, so this is just more like a simple division question. 84 divided by 7 is 12. Okay, what's this chocolate bar example? Yes, this is what we're doing. So yeah, a numerator over a denominator. So you divide the top number by the bottom number. So to convert this improper fraction into a mixed number, you just get the quotient, and then the remainder over that same bottom number, the divisor. Yeah, I wanted to look at this this example. So 5 hikers want to share 7 chocolate bars fairly. How many bars does each hiker get? All right, so yeah, they only have 7. They have 7 chocolate bars left for 5 hikers. Okay, so is it 5 divided by 7? No, it's you want to divide the 7 chocolate bars into 5 equal pieces. So we're really talking about 7 divided by 5. Okay, so it's 7 divided by 5, 7 over 5. Convert that into a mixed number. So 5 goes into 7 one time, remainder 2. All right, so 7 over 5 is equal to 1 and 2/5. All right, so each of the 5 hikers gets a full chocolate bar and 2/5 of another bar. Okay, so there's certainly, since there are 7 bars, yet each hiker gets at least 1 bar, but they also get part of another bar, 2/5. All right, so that's an application. And just one last thing yet. If we want to go the other way, suppose I give you a mixed number. Yeah, sometimes it's more useful to replace the mixed number by an improper fraction. We'll see that later when we're, let's say, multiplying and dividing mixed numbers. So how do you convert a mixed number back into an improper fraction? For example here, example 8, convert 7 1/3 to an improper fraction. Okay, so we want to replace this by something over 3. Okay, so what is this top number? Okay, so we have to convert this 7 into thirds. Well, you can think of it like this. So every 1 is equal to 3/3. So 2 would be 6/3. 7 will be 21/3. Okay, so 7 1/3. How many thirds altogether? Well, there's 21 in the 7, and there's another 1 here, so altogether it's 22 thirds. Okay, so again, yeah, so we're talking about thirds. So 1 is 3/3. If we have 7 of these, that's how many thirds? That's going to be 21 thirds. Plus this third, so 22 thirds. Yeah, there's a faster way to do that. So if you remember this pattern, okay, so here's the mixed number we want to convert into an improper fraction. So multiply the 7 by the 3, you get 21, and then add on the 1. Okay, so we're kind of going in a circle like this. So it's 7 times 3 plus 1. Yeah, here we're multiplying, here we're adding. Okay, so like a circle. And that tells you the top number, that's 22. The bottom number stays the same, so that's 22 thirds. Okay, so we've just seen that pattern, so we get the same answer. Let's try one last one. Convert 11 5/6 into an improper fraction. Okay, so it's going to be first 11 times 6, and then add on that 5. All right, so that's, this is multiplication, this is an addition. So it's 11 times 6 plus 5. That's 66 plus 5, 71. So we need 71/6. So that's the answer. And again, it makes sense. each of these 11, think of this as 11 ones, so each of those 11 rectangles is 6/6. So we get 6/6 from the first rectangle, another 6 from the second. So altogether from those rectangles we get 66/6 plus 5 more here, so that's 71. Alright, so for mixed numbers, yeah, we can convert mixed numbers to improper fractions. We can convert, using this kind of idea, we can convert improper fractions back to mixed numbers, just using a division with a quotient and remainder. Okay, so this is another way to think about converting mixed numbers to improper fractions. So if you have n and p over q, if that's your mixed number, then the improper fraction is given by this formula. Yes, it's like we saw, it's n times q plus p on top, and keep that q on the bottom. Okay, so that's starting to look at fractions.